To continue our discussion of the synthesis of trisubstituted benzene, let's take another example. And remember, what we discussed before is we should adopt what's called the backward approach on how to synthesize a specific target molecule from a specific starting material. So in this case, this is our target. So this is the TM, the target molecule, and this is the starting material, which is benzene. And what we need to look at is the substituents on the benzene ring. Here we have a probyl group. This is a methyl group, and this is a sulfonyl group. So what we need to check is the directing ability, if you like, or the orientation of each of these groups. This alkyl group is an ortho para director. This methyl group is also an ortho para director. Of course, alkyl groups are ortho para directors because they are electron donating groups by inductive effect. This group is a meta director, and that's not surprising because this is an electron withdrawing group by resonance, and we proved that actually that all electron withdrawing groups by resonance are meta directors. So this is something very important. Of course, we know not only the orientation we should look at, it's also the activity, if you like. Whether these groups are activating or deactivating. Obviously, that probyl group is an activating group. This methyl group is also an activating group. The sulfonyl group is a deactivating group. So activation versus deactivation can dictate to us the order, if you like, of steps. Of course, it's always beneficial to start with an active benzene or a more active benzene, if you like, than a less active one in order for the synthetic route to be more efficient. So that's another aspect we should look at. The other thing is we need to look at the carbon relationship between these groups. If you look at the methyl group, for example, and the sulfonyl group, okay, they are in a 1-3 relationship, so they are meta with each other, these two. So these two groups are meta with each other. These two groups are also meta with each other, and these two groups are meta with each other. Now, this is very, very important because we know that the probyl group is an ortho para director, so we cannot do methylation, for example, after attaching or installing the probyl group. The methyl group is also an ortho para director, so again, we cannot attach or install or synthesize the probyl group or attach it to the benzene ring after methylation. That's because the methyl group is an ortho para director. Now, the methyl group and the sulfonyl group are meta with each other, so we can do methylation after sulfonation. So that's also very important to note. The probyl group, of course, consists of 3 carbons, and if you recall, if a group which consists of 3 carbons or more should be synthesized, if you like, following the 2-step sequence, which is acylation followed by reduction. So Friedel-Crafts acylation followed by reduction. So this is very important also because the number of carbons here is 3 carbons. So we need to do acylation followed by reduction. And of course, after acylation, we install a ketone functionality. And of course, ketone, just like sulfonyl groups, are electron withdrawing groups by resonance. They are meta directors. So this is also very important because probably then we should do methylation after the acylation in between these 2 steps. So this is very important to suggest, if you like, a reasonable synthetic sequence, okay, utilizing the directing ability of these groups and also the carbon relationship on the target between these groups on the target molecule. So following the backward approach, probably then installing or attaching the probyl group should be last. In other words, reduction should be the last step. So the compound or the molecule from which to make the target molecule is this benzene, which now has this ketone, and of course via reduction. So this is this should be the last step, hydrogenation in the presence of palladium on carbon. Now it's we have reached a simpler molecule, if you like. Of course, this group now is a meta-director. That group is a meta-director, and this is an ortho-para director. So therefore, methylation should be the immediate step now, or should be the step that we should do right now. So in other words, we need to make this, or we should make this actually from this benzene via Friedel-Crafts acylation. And if you look at this reaction, you would notice, of course, that this group is a meta-director, this group is a meta-director, and of course the sulfonyl group directs here, and of course that group directs here as well. So both groups actually, or the directing ability of both of these electron withdrawing groups reinforce each other in this Friedel-Crafts alkylation or methylation to put the methyl group in the meta position with respect to each of them. So this should be a more controlled or a better controlled reaction than other alternatives. So this is definitely something we should do. Now we have a ketone and we have a sulfonyl group, and both of them are meta-directors. The sequence, okay, or the order as to which of them we should do first, okay, may not be extremely important. We could begin with acylation followed by sulfonation. So therefore, something like this is possible. So sulfonation, therefore, utilizing sulfur trioxide in the presence of sulfuric acid. So sulfonation of this acyl benzene or this aryl ketone should give this product, and of course the ketone is a meta-director. So again, this should be an efficient step or an efficient reaction because the ketone again is a meta-director. So it should direct other groups or other electrophiles on the meta position with respect to it. So this is fine. Of course, it's straightforward on how to make that ketone from benzene. This is, of course, Friedel-Crafts acylation from benzene to this ketone using this acid chloride. Remember, it's Friedel-Crafts acylation, so we need an acid chloride, and obviously the Lewis acid catalyst aluminum chloride. So if we revise what we have done, basically is acylation to put the acyl group. Of course, the acyl group is a meta-director. If we do sulfonation, the sulfonyl group will be directed to be on the meta position with respect to the ketone because this is a meta-director. Now methylation, now we have two groups obviously. We have a ketone and we have a sulfonyl group. Each of them is a meta-director. So whatever electrophile we attach next should be directed to the meta position of both of them. So that's why we get the methyl group on the meta position as directed, if you like, by both groups. Once we have this, the final step is reduction. And again, we did the methylation reaction in between the acylation and reduction so that we can make use of the directing ability of the ketone. So in conclusion now, whenever we want to synthesize a trisubstituted benzene, we need to look at the groups that are on the benzene ring or the trisubstituted benzene or any benzene in general. We need to, if we have alkyl groups, we need to look at the number of carbons, and of course if it's 3 carbons or more as usual, we need to do the two-step sequence in order to synthesize such alkyl benzene. And of course, if you recall, that's in order to avoid carbocation rearrangement. And then of course what we need to look at is the directing ability of each of the groups that are available, and also the carbon relationship, if you like, between them, and this will suggest or will dictate to us the sequence, if you like, or the order of the synthetic route that we should come up with. So this is another example, therefore, on synthesis of trisubstituted benzene.